Okay. Zener diode Schmitt triggers. These are quite straightforward. Okay. The way you say these, what you remember is that you can assume when it's positively saturated here in red. Okay. Current will flow from positive to negative. Okay. So we draw an arrow, a nice thick arrow like that. That helps us look at the diode and say, well, this one here is forward biased, and this one here is reverse biased. If you remember, with a Zener diode, when they're forward biased, they only have 0.7 volts dropped across them, but when they're reverse biased, they have whatever they say on the tin, which in this case is 3.9. Okay? So therefore, you need to then add 3.9 and 0.7 together, so you get 4.6 volts for the positive saturation, and for the negative saturation you go the other way. So with blue we're heading that way, so now this diode is forward biased, giving 0.7 volts across it, and this one is reverse biased, giving 4.3. So the negative switching threshold is going to be minus, because we're doing the minus one, 4.3 plus 0.7 gives you minus 5.
Oh, she's adding together one.
Yeah.
One's minus.
Well, one's always 0.7, the other one's the other value.
Yeah, one.
Okay? That comes to then drawing write that off and do it there. We've got plus 4.6 and minus 5. The switching thresholds. I don't know. So we sort of do on here. We've got 0, 0 here. So if we make that, we make these 0, 5, 10, minus 5, minus 10. That's 0, 5, 10, minus 5, minus 10. So we've got V in on the x-axis, like that. No, actually, I won't do that because we've got V in on the x-axis here and V out on the y-axis. So we basically just plot, we've got plus 4.6, so we plot positive 4.6. So that's here on this axis, and it's also there on that axis, so we plot that point there. And then we'll plot minus 5 and minus 5 on the other axis here.
How would you plot both of them?
So you plot that like that. We then make this into a square here. So effectively, we've got to draw a line across here like this. Oops. Down to there like that. And that gives you hysteresis. Okay. Okay. Now we have to decide whether it's inverting or non-inverting. It's inverting because it's going into the negative input. So we have the tails are going to be high up here.
Wait, what's going into the negative input?
The V in is going into the negative input. Okay. It effectively ends up with two kind of squares here.
How do you know where to put the tail?
Because if it's inverting like this one, then the tails, we've got high input, sorry, we've got a negative input and a high output, haven't we? Whereas this is a high input and a negative output, so it's inverting it. So the tails will be there and there if it's not inverted. So that's your Zener Schmitts.
On the bottom. So it's inverted.